This is Math 156, Maple for Calc 2, and I'm going to go over homework 3. So, for problem 1, we have a certain function f, which is a polynomial of degree 5. So we write the function like this: x to the 5th minus 23 times x to the 4th plus 9 times x plus 11. And if we want to see what the function looks like, we can plot it. Let's plot f of x. And we get something like that. Now, Maple seems to have grafted from minus 100 to 300. That's kind of interesting. Let's experiment with this a little bit. That's what it looks like around the origin. Let's look at a bigger graph. Let's really make it huge and see what happens. Well, so it seems to come up. Here we can't really see very well what's going on. And then it goes up again. So we have to see where it crosses the x-axis, which looks like it'll be in this region. And let's blow out this function a little bit. Let's say we plot it from minus 500 to 0. Maybe minus 100 to 0. Yeah, it comes up. What's going on in here? Minus 30 to 0. Maybe minus 10 to 0. Minus 10 to 10. Well, is it crossing the x-axis or not? It's hard to see. Of course, you can tell that this polynomial, when x is equal to 0, is 11. So probably has to be crossing the x-axis somewhere around there. Let's look at it from minus 2 to 2. Minus 1 to 1. Still can't tell where it crosses the axis. That's a little bit better. So it crosses somewhere around 0.4, minus 0.4, somewhere up there. So this is between maybe minus 0.45 and minus 0.35. And this one is close to 0.5, so maybe between 0.5 and 0.6. Point. There we go. So this point is somewhere around minus 0.42. This point somewhere around 0 minus 0.51. Let's just blow these both up a little bit. Yeah, so this point is about 0.506. This 0.41, 0.42. Yeah, I mean, I can keep blowing it up, but this point's around 0.418. This is about 0.506. Then there has to be another point somewhere out there. So let's take a look at that. Okay. Let's just do something like that. Oh, okay. Huh. Yeah, so that's a pretty good picture. It comes up, crosses the x-axis, comes down, crosses the x-axis, goes up again. This last point somewhere looks like it's between 230 and 240. It looks closer to between 237 and 239. Looks very close to 238. Let's make this 37.9 and 238.1. Maybe it's exactly 238. So that's pretty good. In any case, those are the 3 points where the graph crosses the x-axis, it seems. So I just solved graphically this equation. That's just finding the points where the graph where the equation crosses the x-axis. Let's see what F solve gives us. So if I do F solve equation equals 0 for x, we get, it looks like, exactly these 3 values. Okay. Minus 0.4 plus 0.5, and this one, which is very close to 238. So that's problem 1. Problem 2. So we want to plot two lines on the same graph. So we just say plot, and in curly brackets, we put the two lines, 53x minus 19 and minus 31x plus 7. And there they are. Interesting. Find the coordinates where the lines intersect. Well, it looks like it's around, most clearly between 0.3 and 0.35. Let's just blow that up a little bit. Actually, it's between 0.3 and 0.32 maybe. Oops. Let's get this right. So very close to 0.31. Yeah. So between 0.3094 and 3096, say. Yeah, and you can get it for more decimal digits if you want. What about using fsolve? So, well, should you solve an fsolve? So, oh, actually, and then I also need to find y. So here's my x, and the y is about minus 2.59. So if I just want to find the x, I could just say so we want to solve for x. Oops, no period there. There we go. 0.309. That looks like it's about right. And if we want to find the x coordinate as a fraction, we use solve instead of fsolve. And this is also exactly 13/42. Now, if we want to find the x and y coordinates simultaneously, we could try the following. Suppose you want to solve the two equations. 53x minus 19, sorry, it should be y equals 53x minus 19, comma, y equals minus 31x plus 7. I put the two equations in curly brackets. I want to solve for x and y. I put them in curly brackets. And that's what we get. Just exactly what you see there. And if we want to find the solutions as rational numbers or fractions, use solve instead of fsolve. This doesn't always work, but because the coefficients of the equations are integers, there we are. Those are where the 2 points intersect. That's problem 2. Let's see, problem 3. We're looking at the intersection of two parabolas. So for example, if we plot the parabola x squared minus 5 times x minus 10. That's a parabola going up. If we plot the parabola minus 2x squared, minus 2x squared plus 8x plus 171. You get a parabola going down. And if you want to plot the two of them together, there are a couple ways to do that. One is just put the two functions we're graphing inside curly brackets. There they are. One parabola going up, one parabola going down. Maybe I'll just graph it from minus 10 to 10. Oops, better go a little bit further. This 15. There we go. That's a little nicer. So here's the intersection of these two parabolas. Yeah, and we want the points of intersection. So we can do it graphically, or we can do it algebraically. We could just use this f-solve, for example. So we want to find when is where do these 2 points? That's one parabola. This is the other parabola. So, now this is interesting. So we're only getting 1 point of intersection. This is x is around 10 point something and y is 43. We're just getting this point. So how do we force Maple to also give us this point? We need, let's try this, see if it works. Let's say we want to find a solution where x is negative. Suppose we look, let's try this, x equals minus 10 to 0. And let's try y is 0 to 100. There we go. So you give it a range of values to look for x and y, and you get exactly the right thing. So you could either blow up the curve around these 2 points and get these numbers, or use f-solve. Problem 4, that's just computing some limits. They're all the same. Limit is a function which has an expression with a capital L and a lowercase l. So if I write capital L, let's look at E. That's the limit of the sine of 6 times x divided by 14 times x, comma, as x goes to 0. So this won't give us the answer. Oops, this should be 1 equal sign. This will give us the statement of the problem, because I used a capital L. If I use a lowercase l, I get the answer. And if I put them together, I get a very nice expression. I want a capital L on the left and a lowercase on the right. And this limit is equal to 3/7. And the others are done exactly the same way. Not every command, actually very few commands in Maple have an uppercase and lowercase forms, but limit does. Let's look at problem 5. Have to remember always to save your worth frequently. So let's save it. Problem 5 is the derivative. Again, there's one command for the derivative. Well, actually, there's two, but one for the derivative of a function. Suppose we have the function x goes to -2 times x divided by the square root of x squared plus 1. And the simplest command for the derivative of the function is capital D. Capital D of f is this function, x goes to this. Or sometimes looks pretty if you write capital D of f of x is that. That's the derivative. And the others are very similar. Okay. Problem 6, write a loop to plot the graph of the function. There's the function. The different values of the parameter. So, let's write this as f is the function x goes to. Well, let's just do it easier. For n from 0 to 10 do, and then shift, return to return, and do. I always like to put that in right away. And what do I want to do? I want to plot x to the 4th minus 3 times x squared minus 4 plus n. Actually, that's all I need. Maybe write an n comma there just so I know which n I'm doing. Let's see what happens. Oh, wow. Okay. N equals 0, 1, 2, and so forth. So for this function, well, those are what the graphs are. Now, the only problem is they're hard to see. Can I make it bigger? So use the graphs to determine the values of n for 0 to 10, where the function has 4 solutions. So this is a 4th degree polynomial. Polynomial of degree 4 has at most 4 roots and those 4 solutions. So how many of these? Can I make this bigger? Let's try something else. Suppose I write this as x goes from -4 to 4, and y goes from -1 to 1. So here, this crosses the x-axis at 2 places. This is 2, this is 2, this is 2. This looks like it crosses at 3, 4, 4, and the rest, none. So for which of these graphs does the function have no solution? 7, 8, 9, and 10. So So let's write this all out. So four solutions. Three solutions. Two solutions. One solution. No solution. Zero. So you look at the graphs, no solution is n equals 7, 8, 9, 10. Four solutions, 5 and 6. This one I can't see very clearly, so I'll go back to that. Two solutions, 0, 1, 2, and 3. So let's take a look. This has the two places where the graph crosses the y-axis. 2 here, 2 here, and 2 here. This might be 3, might be 2, might be 4. And then these are 4, these are 0. The only one I can't tell is when n equals 4. So I'm just going to graph that separately because I'm curious. When n is equal to 4, aha, minus 4 plus 4 is 0. It crosses there exactly one place. So three solutions at n equal 4. So those are the answers. And we're done.